Hello everyone, this is the Trash Panda Dev, and today we're starting a series on using Python for data analysis and visualization. Whether you're a student, doing research, working with business data, analyzing survey results, or just curious about what Python can do, this is a series for you, obviously. Python is incredibly powerful for working with data, creating beautiful visualizations, and doing statistical analysis, and the best part is it's completely free. What we'll be covering today, we'll be going over um, how to get everything set up so you can start doing real data analysis with Python. By the end of this video, you'll have a working environment and will create your first professional looking graphs and data analysis. No prior programming experience needed, honestly. First things first, we need to install Python onto our computer. But one of the things that we need to do is make an important decision. There are two main ways we can do this. One is just by downloading regular Python. You do that by going to python.org on this page. Install packages individually using pip. Learn how each piece works and it's more universal and transferable. Or our other option is Anaconda, which it's one big download that includes Python and 250 data science packages. Everything works together out of the box, but it's a really large download. It's around like 3.5 GB to 4, which may not be worth it for some people. I'm going to show you the approach with Python only though for now. The reason is because Anaconda is popular and there's nothing wrong with it. And many data courses and companies do tend to use it, but I think it's a lot better if you learn to use Python on its own first, because you'll be more prepared for real world scenarios, and you're basically learning how to use it the proper way. You'll also have an easier way to understand which each package does. When you download Anaconda, you get 250 packages, and who knows, you might use 4 or maybe 10 the entire time that you have it, which you don't even know what the rest does. So it's a good idea to just start with the ones that you do know and you know exactly how to set it up. This is also exactly how it works in data science, so you know how to set up your own computer or another computer. You don't always have to download 3 gigabytes worth of packages. Obviously, it's much lighter weight, and when you encounter Python in the wild, you'll know how to set it up properly, as I said earlier. The downside, though, we'll need to install a few packages. That will be manually, and there's a slightly more bit of like work and a chance of things going a little wrong. But if you learn how to troubleshoot through that, it'll be easier for you to understand how to do in the future. And every computer is different, so who knows. So as you go to python.org, when you're in the main page, you'll be here. You should click on downloads. The newest version is Python 3.13.5 right here. I would go with this specific release. This is the newest, and you'll be prepared to use it. And after clicking on that, you scroll down, pick the installer that you need. I have Windows 64-bit, so I'm going to pick this installer. I already downloaded it, so you'll see that, but I'll re-download it again so you guys have an idea of how to do it properly. So whenever you're ready, you just click on install now, let it install. It shouldn't ask you to do anything else, so you should be perfectly fine. If it does ask you to add Python to path, you should check that for now. You could always change that later on. But once you're done downloading, that's perfect. So one of the things I overlooked in this video was that some of you guys may not have VS Code downloaded or may have never heard of VS Code. So to download that, you can just go to code.visualstudio.com or just look up VS Code on Google, and the download Visual Studio Code website should be there, and it'll have like the 3 operating systems of Windows, Linux, and Mac, and just pick the one that you need, download it. There's many videos on YouTube on how to download it properly, so you guys can go through there and do that. And yeah, we're gonna continue with the video now. This is all set up. Next thing we do is install all our packages. So we do pip install pandas matplotlib seaborn jupyter plotly and scipy. So when doing pip install, you can do them individually in the sense of pip install panda, then pip install matplotlib. But if you want to install them all at once, you would just do a space between each package. Panda is data manipulation, like it's like Excel, but programmable. Matplotlib is basic plotting and graphs. Seaborn does beautiful like statistical visualizations. Jupyter is interactive, an interactive notebook. Plotly is interactive web-based graphs, and Scipy is a scientific computing statistics. And then when you press enter, it might take a minute or two. That's pretty normal. It's gonna download everything, and it should stay successfully installed. And don't mind these lines of code. That's just normal. Then the next thing to do is let's do our extensions. So as you can see, there's a couple extensions here, but the main ones you want to download is Python, which just gives VS Code the ability to understand Python code. You should do this one. It should be by Microsoft. Just download that one. It should be pretty simple. Next one should be Jupyter. Same thing by Microsoft. Then the last one is Data Wrangler. And the one before Jupyter, it lets us like create interactive notebooks. And then Data Wrangler, this gives us like a visual way to export our data, like Excel, but better. It might take a minute or two for you guys to download, but you know, you can take your time, pause the video right here, and continue. And whenever you're ready, we can continue to the next part. So whenever you're ready for the next part, we'll do open folder. Then after that, we will create a folder, and we'll name it. Let's name it data underscore analysis underscore project. And then we click on that and select that folder. Yes, I trust the authors, because that's just me. Then after that, we will do the next thing we will do is set up like the proper folder structure for data analysis. So we would want to have a data folder. You can just click up here to do new folder, or you can right click and then click on new folder. The data folder is where we'll store our CSV files or data sets, so on and so forth. A notebooks folder, which will be our notebooks. Then our scripts, which will be our Python scripts that we could reuse in other projects, or just reuse in general. And then our output folder, and that's pretty much what we need to build for the structure. And then we should create the next step should be creating a Jupyter notebook, and we'll just click on notebooks, right click on it, new file. Then we will name it 01 underscore getting underscore started, because it is your first project. And then before we press enter, you do period IP Y and B. The IP1B extension just tells VS Code this is a Jupyter notebook. Notice how VS Code automatically recognizes it and has a little icon to the left of it, and it also creates a different interface. So you know that much. Oh, before I forget, here you want to make sure that your Python is selected. So we would want to do Control Shift P and search up Python select interpreter. You should search this up, click on it, and then it should show you the Python path. And then just click on that as well, and it should work for you. Sorry for just bringing that up now, but that is one of the steps that you should do. And then after that, we should be ready to start coding. This is the exciting part, and whenever you're ready, just click on code. And every time you start a project and you download packages, a lot of the times you have to import those packages. So by doing that, you write import the package's name or the package name, and then that's pretty much all you have to do. But for the reason of like saving time and not having to write certain words over and over again, we'll do as PD. So the reason for is you won't have to write pandas all the time. The as part just creates a nickname for pandas, and we'll just nickname it PD. And besides just typing pandas over and over again to use pandas, we'll just type PD. Next thing, we'll do import matplotlib. Actually, it's pyplot. There we go. Matplotlib that pyplot as pit. Oh nope, pit. There we go. And or not pit. Sorry, plot. There we go. And then the next one should be import seaborn as SNS, and then import numpy as np. So matplotlib is for basic graphs, seaborn for beautiful statistical plots, as I said earlier, and then numpy is just for math and random data. We'll use that later, and I'll explain why. But for first, to check that Python is working, we'll just do a quick print statement, and we'll do welcome. I don't need to do a space here. Oh, I did double space. Okay. Welcome to Python for data analysis. And do another print statement just to say that all the libraries and packages are working. Loaded successfully. And to check if it's working, you can either click here to run this specific cell. I guess I forgot to explain, but when using a notebook, you'll have cells. Each cell does a specific code, and you can separate your work without having to create files for each thing. It's just easier. It'll be easier to read. You won't be overwhelmed by just having a lot of code. And not just that, when you have big amount of outputs like different graphs or processing data, you may want to do that with its own cell, because as let's say I run this real quick, however long it takes, you don't want to have a long output and have to scroll through each thing just to see it. So it's good to have a different cell where you can code and have a different output, and knowing that you can find each thing without having to go through a bunch of data or a bunch of graphs, and it would just be easier to read. An easy way to create a new to run a cell is also by doing shift enter. as you can see, I had nothing there, so I didn't run anything. So as you see, the message printed, and that means Python is working. The import statements are working as well. It's not a made up thing, so we know it's perfectly fine. And on to the next cell. All right, so the next part will be learning how to create some sample data to practice with. I'll create a data set that demonstrates common data analysis scenarios. But to save time, I'll just paste how to do it. Obviously, you probably won't need to learn this anyways. This is more just so that we have some sort of data to work with. In next video, I'll probably put some CSV files to work with and have some real world scenarios. So to explain this, we use np.random.seed 42. All this does is generate the same random numbers every time. Just think of it as a way to like create random data, but for it to be reproducible, so it's not that random. We also created a Python dictionary, as you can see right here. Python dictionary, just think of it as like a filing cabinet where each drawer has a label and a value. So the label will be keys. So the keys are this, whatever is before first, and then the values will be what's after. So participant ID from range 1, and then participants plus 1. The reason we do the amount of participants plus 1 is because with Python, the last number technically you don't count. So if I want to do a range from 1 to 50, I'll do 1 to 51. An example of me showing that is right here from 1 to 11, but the scale is from 1 to 10, so it stops at 11, but it doesn't actually use 11. Then we converted the data into a data frame. df is just a conventional way of like a regular variable name. It's just a conventional way to say that it's a data frame. So we do this by saying pd.dataframe, and then in parentheses we put data inside. Then we do print create data set with the length of df, which should be 50. So with 50 participants. And then to show the first 5 rows, we just do df.head. And then after being properly set up, you can just press run. It'll show you the first 5 rows. So these numbers are the rows 0 to 4, so it's just 5 rows. Then the columns are the data, so participant ID, age, productivity score, sleep hours, work type, and satisfaction score. Before we create graphs, let's try to explore our data. And like, obviously you can't create graphs if you don't understand what you're trying to do. So let's be real researchers, explore the data that we have, and by doing this we can just do print statements. So we can create a quick print statement with a string, data set view, or overview would be a better word. This would just be like a title holder for now. Then we can do print f quotations shape, and then curly braces df dot shape 0, and then outside of that we do people. The df shape like basically tells us the dimension of the data. Think of it like asking how big this table or the first number is in rows. The second one that we're gonna do now is basically same thing, but this one tells us the column. So we do df dot shape 1. So yeah, so row 0, column 1, and then we're gonna name that one variables. And then the next one should be age range colon curly braces df, and then we do brackets age, and then dot min, so we're getting the minimum age in the data set, and then the next one to df age again, but this time we're getting the max, and we do that. So here it just says age range, gives us the first number to the max number, and then years, ending the sentence. Then print we do what could be the next in? Oh, we can get the mean. Okay, so we can do so quotations average productivity score, and we'll do curly braces df dot shape brackets productivity underscore score, and then outside of that we do mean to get the mean, then do that, and then we should do colon dot 1f right there, and that should be it on that part. And next we would just do print basic statistics can't type today, and colon, this should just be a small little header for where we're printing dot describe. So the df.describe, it just gives us a statistical summary. Like it counts the values, the mean, standard deviation, quartiles. It's like getting a quick like health check of your data. Obviously min max, you already know that. Mean just gives you the average, and then as I said earlier, the df shape tells us the dimensions of our data. So just like asking how big the table is. So the first number is the rows, so we're doing people, and then the second number is the column variables. And then when we run this, indices must be integers or slices. Oh, because I did df.shape, sorry. It should just be df and then brackets productivity score dot mean. Yeah, okay, perfect. So this should work now. So as you can see, if you want to see this part, it does dataset overview, tells us that there's 50 people, and then it tells us that there's 6 columns. So 1, 2, 3, 4, 5, 6, obviously. It tells us that the age range is from 18 to 37 years old. The average productivity score is 5.7. And the basic stats using df describe shows us how many participants are in each column. Obviously it's 50, so there's going to be 50 in each one. None of them will be blank. The mean for each thing, so the ID, age, so on and so forth. This one is standard deviation, and the quartiles here, the min, the max. Perfect. After that, we'll just create a new cell. And in this new cell, we'll get to like the really exciting part, which is like we can create professional graphs. And I'll try to get through it as quickly as possible. I know this video is a bit long, but we'll do, let's create like a professional visualization. So we'll do plot figure, then fig size equals to 12, comma 5. The plot figure, this part right here, it just creates a canvas for our plots. The numbers are the width and the height, so width 12, height being 5, and they're all in inches. As you can see, we use plot from matplotlib.plyplot, so we just named it PLT for short, and that's why that's working there. You can rename it anything you want, but this is just conventional and just easy to do. Then the next part will be, let's try to create a plot. So we'll do, I'm just writing a little comment letting us know that this plot will be, so plot 1 for productivity by work type. So what we'll do here is, again, plot dot subplot 1 comma 2 1. The plot dot subplot part, it just means create a grid with a row of 1 and with 1 row and 2 columns, and it put this plot in position 1. It's like dividing the piece dividing a piece of paper in half. And then the next part would be SNS dot box plot parentheses data equals df comma x equals work type. Then so that makes the x-axis equal to work type, and then the y-axis equal to productivity score underscore score. And then another comma, then we do palette equals to set to plot title. So we do plot title productivity scores by work type. So that'll be the plot title. The next part should be plot y label. So the label at the y-axis, which would be productivity I can't type today, excuse me for that. Productivity score from range 1 through 10. And then the last one should be plot dot x label. And this one is work type. After that, we do plot 2. So let's do plot 2 being relationship between sleep and satisfaction. So we'll do plot dot subplot. I'll just copy and paste this. we'll do SNS dot create. Oh wait, no, sorry, not create. SNS dot scatterplot. That's what it should be. Then it'll be data equals df, then comma x equal sleep hours. The next one should be y equals satisfaction score. Next one should be hue. Hue just means like the color of the points are differently based on like the variable. So like we'll do like hue for each one, and then after that we do alpha equals 0.7. After that we do plot dot title. Oh wait, not in here. Plot dot title, and that'll be called sleep hours versus satisfaction score. Then last thing would be the last two things would be plot y label parentheses hours of sleep per night. And then wait, no, this should be x. X should be that. And then plot y label should be satisfaction score. Data equals df just tells the plot function to use the data frame that we have. X and y are the specific columns to use for each axis. And then 1-to-1 plot set plot 1-to-1 means create a grid with one row and two columns and put this plot in a position of 1. That should be everything. So I'll just run everything at once so that you can see it all run together. And after everything is done, oh yes, sorry, excuse me. Plot dot tight. We would just do this so that we make sure that the plot doesn't overlap with each other. So layout, and then plot dot show. Forgot some important stuff. Okay, so we can just rerun this again. Why is it showing only one thing? What did I do wrong here? Oh, okay. So the reason I figured that out. Okay, so the reason it's not working is because we didn't do for each participant. So it just kept picking the last one. So if we do it again, okay, there we go. That's perfect. Now it's picking random ones. And then if we run this last one, there we go. All right, perfect. Excuse my errors and sorry for making this video so long. But as you can see, the box plot shows the distribution of productivity scores across the work types. You can see the medians, the quartiles, and outliers. The scatter plot shows the relationship between sleep and satisfaction with different colors for work types. Oh, that was so awkward. But look what we did with this time. We were able to set up Python for data science. We created organized project structure, as you can see here. Generated and explored data samples, made professional quality visualizations, and basic statistical summaries. So to save, we can just do Control S. Your notebook is saved, and you can come back to it anytime. Your entire code is also saved, outputs, and the graphs that you have. In the next video, I'll show you how to load real data from CSV files, learn data cleaning and preparation techniques. We'll also create more sophisticated statistical visualizations, and we'll work with actual datasets and comma analysis. If this was helpful, hit a like and subscribe. We're building a complete series on Python for research and data analysis. And see you next time. Bye.